Hi, my name is Carlos Rivera. I am the Global Product Specialist for FEFLOW, and today I would like to show you one of the newest features of FEFLOW 7.4 in the May release 2021. We have introduced a new block in the problem settings dialog called Meta Information. The idea behind is to have a tool to support you documenting your product, your model changes, and others. Groundwater modeling is a comparative work and involves multiple tasks. In the version of FIFLOW 7.4, you can document all these different changes in one single place. These changes can be technical information like hardware, license, solver, parallelization settings, among others. You can document what type of changes you have done with the FIFLOW model, when this happens, who has done these changes, and any other type of information that you can even imagine. The documentation is possible through the FIFLOW graphical interface, Python, and FIFLOW console. Let us look in detail how this meta information framework works. We are in FIFLOW 7.4. We can go to the menu Edit, Problem Settings. In Problem Settings, we find this new option, Meta Information. Meta Information consists in a description scenario, flow and mass transport in Berlin, a system meta information. This is automatically defined by FIFLOW based on the Windows installation, architecture, and hardware definition of your system, CPU, processors, physical cores, logical processors, and so on. The type of license that you use, and standard information like name of the file and when was the latest modification on this. Below, you have a user meta information section. Here you can define in principle any type of information that you would like. This start with creating a new group of information modeling tasks. Inside this group, you can add different pairs of information, properties like name. I would like to define here what is when was the latest change of the model domain. Let's say the 4th of January, we create the super mesh. Then on the on the 7, we we finalize the 2D mesh and so on. So you can also define who has been working in the project, what type of parameterization you have done, etc. You can export this information if you would like to use this type of template for different projects. The export is creating a FIFLOW XML file, and you can import the same in the next project, and you can just basically update the different pairs of information name and values. If you press save, save the document, all this block will be stored inside the FIFLOW file for the next time. But let us do something more efficient. I have prepared a second example where we will read the Excel table. In this Excel table, we have documented the different modeling steps, when and what exactly has been done in the FIFLOW model. Our task is to migrate this data inside FIFLOW because we just want to have everything inside the file. We don't want to carry out multiple Excel tables, text files, and so on. We have this new framework. We can document the changes directly in the FIFLOW interface. For this task, I have built a simple Python script, and in the next minutes, I will show you how this script works. For the tutorial, we require the installation of PyChar. This is a free Python interpreter, FIFLOW 7.4, and 3 Python packages, pandas, XLRD, OpenPyXL. We start importing the FIFLOW Python packages. Import IFM. We import pandas as PD, and I would like to know what is the FIFLOW Python version being imported. This is only necessarily if you have multiple FIFLOW versions installed in the same machine. Of course, we need to load the document, and for this we use the method ifm.loadDocument. Fem file is the location of our FIFLOW file. The entire data of the model changes and documentation is behind an Excel file, model journal. This file is imported in Python through a method behind pandas, pd.readExcel. This creates a data frame, the if, and the data frame can be split in two variables, tasks and dates. This is exactly the number of columns that we have in our Excel file. For a easy manipulation in Python, I decided to convert these variables, tasks and dates in Python lists, list tasks and list dates. So basically, I go through a loop and then I extract the information behind dates and tasks and convert this information already in strings, which will be stored and appended in a list in Python. The entire structure of the FEFLOW metadata block is based on XML strings. For an easy manipulation, I would recommend you to define a template like this. This template can be easily created. For example, if you create some groups and tabs in the FIFLO graphical interface, export the XML file, and then you just basically copy this text inside your script. In this example, I have a user metadata block open here and closing here. We have two groups, team and task. That group team is already complete with three users, three different modelers names, and task is the part that we need to fill in this script. For this, I simply add a placeholder called tag user date. In the next lines, we are going to find this location and replace this tag user data by the real data. For this, we just simply use some strings manipulation. We have an empty string called task strings. We go through all the different tasks inside list tasks and we write the tasks and the strings in a way compatible with XML. We define a task, we define the date when this task happen, we separate this information with a minus, and then we define what is the task being done. We close the information here, and at the end of the line, we append a new line. We repeat this operation until the number of tasks are done. Finally, we replace or we create a new variable called user data by using the template XML template and replacing tag user data by the information task strings. We use a new method in FIFLOW 7.4 to push this data inside the FIFLOW document, set user metadata and the name of the string. Finally, we save the documents with extension .fem to keep the changes and see them later in FIFLOW. Let's analyze the results of this script. On the right side, you see the Excel file or the Excel table with the two different columns, date and task. We have embedded this information inside FIFLOW in the meta block. I can look the first block, which was defined directly in the Python script, and the second block added here. Let's make some demonstrations. So I would like to add a new different task, calibration transport manual, FIPS calibration. Save the file, close. We will go back to the Python script. We just need basically to run the script, run metadata, prints the FIFLOW kernel version 7.4 update 1, no errors. We go back to FIFLOW, reload the file, we go back to the problem settings, met information block, and we look, we have added two different tasks to our documentation system. Would you like to get more information about FIFLOW? You can always visit our landing page. Here we get an overview of the different modeling capabilities in groundwater modeling, contaminant transport, and heat transport. I'm Carlos Rivera, the Global Product Specialist for FEFLOW. Talk to you soon. Bye.